Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. Happy New Year to you all. This is the first video that we're doing of 2022, and it's a great one, actually. It's a really good interview with Paul Mitchell, President and CEO of an organization called Energy Systems Network. Now, Energy Systems Network is a non-profit organization backed by government bodies as well as private companies, and it develops technologies to power the cars of the future. It's also the organizer of the Indy Autonomous Challenge, which is a racing competition using high-speed autonomous cars. It involves many teams from different universities developing groundbreaking, pioneering technologies. It's a fantastic event. It's been going on for about 3 years. And for the first time, the race will be held at CES.
My name is Paul Mitchell. I'm President and CEO of Energy Systems Network. We're the organizers of the Indy Autonomous Challenge. At Energy Systems Network, we work on a wide range of advanced energy and transportation initiatives. And for the last 3 years, one of those initiatives has included setting up a global prize competition for developing and then racing fully autonomous race cars. So that's been a passion of ours for the last 3 years, and we're excited to be preparing for our second event here at the Las Vegas Motor Speedway as part of CES.
Great. Excited to be interviewing you as well, actually, Paul, and we're talking about this fairly pioneering, not fairly, but pioneering event, a groundbreaking event in a metaphorical sense. But first, I've got to ask you about where you are, the background. I mean, it looks epic. It looks fantastic. Explain where you are and give us a little explanation of, a little guided tour of where you are.
Sure. So I'm talking to you live from the Las Vegas Motor Speedway. It's a super speedway in the city of Las Vegas, not far, maybe 20 minutes away from the Las Vegas Strip, where all the casinos and hotels are. It's a 1.5 mile oval, and it's got pretty significant banking in the turns, which has actually proven to be helpful to our vehicles to achieve some higher speeds and go into those turns more fast, safely. And today and every day this week, and we will be practicing here, really starting here in the next few minutes. You'll probably may even see some of the cars start to go around, and we'll have practice every day until January 7th, when we will run our competition here at this wonderful facility.
Okay, just one more question about the stadium. Normally, what is it used for? I mean, I'm based in the UK, so the kind of racing we see on the news and on the telly, or if we're fans of it, follow it, the Formula One, where the tracks are in different locations all over the world, and they're completely different. They're more, I don't know, more complicated. They're not oval shaped. I've heard of IndyCar racing, but for those of us who don't live in the US and are not familiar with IndyCar racing, give us a brief overview. I imagine that's the stadium. In that stadium, there's normally IndyCar racing.
Yeah. So this track is used by NASCAR for stock car racing. It has been used in the past for IndyCar. They have not been here in a few years, but they did race here for a number of years, and they used to hold the series championship race here at the Las Vegas Motor Speedway for IndyCar. So in the United States, ovals are quite popular form of racing, particularly for NASCAR. They run a lot of oval courses, and one of the nice things about an oval like this, especially with the wide banking and the wide track, is that it allows NASCARs and even Indy cars to sometimes run 3 or even 4 wide. So if you can imagine, cars going around at, NASCARs are probably 180 miles an hour. Indy cars are, 220, 220 miles an hour, and they're wheel to wheel, right next to each other. And that's part of why, people find these ovals exciting. We chose to race on ovals first at the Indianapolis Motor Speedway, where we held our first competition on October 23rd, and now here at the Las Vegas Motor Speedway on January 7th. We chose to tackle the challenge of ovals, really because our objective was first and foremost to demonstrate fully autonomous vehicles at high speeds, and ovals are really a good platform for achieving very high speeds. So that allows us to go 150, 160. Someday we hope to reach as much as 200 miles an hour, without having to brake and turn that like you would in a road course that is more familiar to Formula One.
I think it's absolutely fascinating. We'll get onto that in a minute, but what I thought I'd do is give you the opportunity to talk more about the Energy Systems Network, and we'll talk about that because we are a technology news website, and energy being a very crucial technology to some of the things that we talk about quite regularly. So I'm just going to share my screen and go to the Energy Systems Network website, and you can explain to us a bit more, elaborate a bit more about what you were saying about the company or organization. What is it?
Sure.
Is it a private organization, or is it sort of a government-backed thing, or is it a consortium of companies? What is it?
Yeah, so actually it's a bit of all the above of what you were just saying. So Energy Systems Network is based in Indianapolis, Indiana. It is structured as a United States nonprofit corporation. So we do get some funding from the government, both the state of Indiana and the federal government. We also receive significant funding from industry because we have kind of a consortium of industry partners and board members that will invest in our projects. And then we also we'll get money from philanthropies, so from foundations that want to support the work we're doing. All of our projects are typically, developing and validating new technologies in a commercial environment. So if you have a new electric vehicle platform or charging infrastructure, or you're trying to validate some new business model, such as vehicle to grid charging or electric buses or smart grid technology, renewable energy, hydrogen technology, of course, autonomous vehicles, we will develop projects with industry partners, with government partners, and provide project management and kind of visionary leadership to ensure that those pilot projects are successful and that everybody involved learns what it is that they hope to learn during those projects, which typically last for us 2 to 3 years from start to finish. So we don't run programs that are long term. We run projects that have a start and a finish. And those that are going to run longer term, we actually spin those out and they become their own companies or their own entities. So even with this Indy Autonomous Challenge, maybe in the next year, if it continues on, it probably will spin out of Energy Systems Network and become its own entity, and we'll move on to the next endeavor, if you will.
Well, I'm always an optimist about these kind of technologies, but I don't think I'm the only one about this particular technology, and I can see it spinning out into a very successful venture. In the long run, I think it may take a few years, but I think in the long run, it's got a, in my opinion, my humble opinion, I think it's got a great future. People love racing, watching racing, and it's so intriguing. The idea of autonomous racing and how good or skillful these autonomous cars can be. But let's just dwell on the energy part of it first, because obviously, as
Sure.
you know, it's a critical critical question. This. Just a quick question first. The energy systems network. When you talk about energy, you are talking mostly about electric, aren't you? Or do you deal with other sort of energy networks and systems?
So most of our projects deal with the electric grid, either on the grid side, where we're doing things like the generation of renewable energy from solar or from wind, working a lot in advanced battery technology. We launched something called Battery Innovation Center, which is really the foremost battery testing, certification, and prototype labs in North America. And that organization now works with 300 or 400 companies around the world to help them advance battery technology. And then where we kind of got our start in transportation was that intersection between battery technology and transportation, right? Which started with electrification, electric vehicles, but now has moved to not just electrified vehicles, but connected and fully autonomous vehicles, which are really, I think, in many ways, an outgrowth of our experience working with some of the earliest deployments of electric vehicles. We actually led the first commercial deployment of an electric vehicle in the United States. It was an electric car called the Think City. It was a very small kind of funny, a bit funny looking for at least the United States, a small city car that was fully electric, and we deployed it with the state of Indiana's Department of Natural Resources as a security car that could go around state parks, and they liked it because it was quiet and it wouldn't disturb the people that were in the park enjoying the nature. And so that was actually back in 2008. So we've been involved in some of the very early pioneering efforts in a variety of industries, and now here we are providing that same kind of pioneering leadership in the world of autonomous vehicles, particularly the concept of high-speed automation.
Mm. Yeah, I would say, dwelling on the page earlier about energy storage, and I don't want to be too geeky and technical, but as far as I understand, it's a big issue, energy storage of electricity, battery technology, basically, whether you're talking about batteries small enough to fit inside a car or giant batteries that are, located next to a power station, for example. I mean, I was really surprised that I think only about 2 years ago, I learned from another journalist who works in that field that electricity that we get at home is basically a live network. It's not like in my home, I'm using electricity that is stored in a giant battery somewhere. It's actually a live network. If the power station goes down, my electric goes down. And that never occurred to me, but it's at the same time, that brings up the question, why aren't there batteries that can store massive amounts of electricity so we don't have power cuts and things like that? And why doesn't it exist? The other related question is, I mean, I'm not really an expert, but I've read these things, and there's a kind of a competition going on between lithium-ion batteries and hydrogen fuel cells, and the proponents, the supporters of hydrogen fuel cells say that that's better because you can store hydrogen and hydrogen fuel cells. The idea of having a network is better to use hydrogen as the basis for that network. What's your opinion and what your observations about these kind of questions?
So I think in terms of advanced battery technology as a solution for storage on the grid, and what you're really referring to with the question of can batteries be used to offset major grid outages at a wholesale level, not at an individual home or maybe even individual business, but at the sort of broader grid system level or network level, as you suggested. The challenge there is that lithium-ion batteries and batteries in general while they certainly can work for the storage of electricity, that's been proven. It's being proven every day with electric vehicles, and it's been used for a long time as backup power for things like cell phone towers and other, critical infrastructure. The challenge is bulk storage requires multiple megawatts of storage. The grid operates on a gigawatt level, not a kilowatt level. And so if you're trying to store hundreds and maybe in some cases thousands of megawatts worth of power, the number of batteries you need is substantial. The batteries would essentially be stacked and look more like a data center and would take up large structures that would need to be located next to the grid. The engineering and integration of those kinds of systems, while it's being done in projects throughout the world, certainly in California, there's been a lot of large-scale storage projects. There's some large-scale storage projects in other parts of the United States and around the world, particularly in Asia and China, Japan. It's still expensive. It's not necessarily the best use case for lithium-ion battery technology. There are some other alternatives that industry is looking at that allows you to do bulk storage. Historically, there's been things like pumped water stations. There's thermal storage, mechanical storage that use more physics-based approaches. And then just working on battery chemistries that maybe are more low cost and also robust in terms of being able to store large amounts of energy. The alternative, which is certainly you have a group of innovators and entrepreneurs and policymakers who advocate for more distributed storage. So rather than trying to store megawatts of power at the grid level, in large structures that would look like maybe a data center, we could also have batteries at everybody's home or everybody's business. And so you would have smaller batteries, more distributed across the grid, so that if the outage occurs in your home or maybe in your neighborhood, there would be a smaller battery that would provide backup power just for you or for you and your neighbors until the broader grid system is brought back on. So that concept of distributed energy storage versus bulk storage is a big debate right now in the grid industry. You asked another question about hydrogen versus battery storage. And there's really pluses and minuses to both of those technologies. In our opinion, at Energy Systems Network, we've done extensive work in the battery space and know a lot about it. And we're actually getting ready to launch a pretty ambitious hydrogen project because we believe hydrogen also plays a real important role. My own opinion is that hydrogen probably is a more near-term viable option for over-the-road trucking, which is a big industry in the United States. So if you're talking about big, we call them 18-wheelers or semi-trucks that are traveling and traversing the U.S. on interstate highways, those are very difficult to run on fully electric just because of the weight of the cargo that they're carrying, the number of miles that they need to run before stopping and charging. And so hydrogen seems to be a better alternative for that kind of long haul trucking if you're trying to go to a more green transportation fuel. And I think hydrogen also can play a role in providing industrial energy solutions, whether it's for refineries or for other industrial manufacturing operations. In that instance, hydrogen is really competing more with natural gas as a resource versus electricity. But no, I think there's definitely a role for hydrogen. At the same time, it's not a zero-sum game. There are and will continue to be the use of advanced lithium batteries and other battery technology for electric vehicles, particularly for passenger cars, light-duty vehicles, residential storage systems like we just talked about. So I think both technologies will live side by side for years to come, and there's plenty of growth for investors and entrepreneurs in both those industries.
Okay, so let's move on to the Indy Autonomous Challenge. Yeah, tell us about your involvement with that, and from the beginning, when is it going to take place? January 7th is when it's going to actually happen. Behind you at the stadium, tell us about that.
So, Indy Autonomous Challenge was started almost 3 years ago now as a idea to bring back the impact that the DARPA Grand Challenge had on the autonomous vehicle industry. That competition that the U.S. government through the Department of Defense DARPA agency ran in 2004, 2005 really was the birth of the modern autonomous vehicle industry. And you had university-based teams that competed then for $1 million prize, and teams from Carnegie Mellon and Stanford and Michigan and MIT and others, participated in that, and it led to a lot of technology innovation, a lot of corporate startups that spun out of universities that today are very successful companies like Waymo at Google, and Cruise, which is partnered with General Motors, even some of Uber and Tesla's autonomous technology and entrepreneurs really were alumni of that DARPA Grand Challenge. And so we looked and said, boy, could we try to do that again for a modern era and tackle a new challenge, in this case, high-speed automation. DARPA was really about just validating that autonomous vehicles could work. And since then, you've seen a lot of focus of industry on low-speed automation in urban and suburban environments, but not enough focus on the edge case of extreme high speeds, which is important because if you're going to run autonomous vehicles eventually on the highways, they're going to need to encounter each other at speeds in excess of 80, maybe even 100 miles an hour. And there's not really been a lot of testing and validation of whether the components and the hardware and the software can handle those kinds of operating conditions. So we put out a grand challenge, $1 million prize to leading research universities from around the world to compete in a racing format using fully autonomous race cars that our organization worked to develop in partnership with Dallara, a race car manufacturer, and also working closely with Clemson University, who helped with some of the design and engineering of the race car. And we originally partnered with the Indianapolis Motor Speedway. We thought it was a great venue to showcase this technology. The Indianapolis Motor Speedway is maybe the most iconic and famous track, certainly in the United States, one could argue in the world, and has been home to countless firsts in terms of automotive technology, the first rear view mirror, the first seat belt, all kinds of early innovations. And so for 2 years, teams competed first virtually, doing simulation rounds, and then starting in June of 2021, the teams came to Indianapolis and began operating with real race cars. We had 41 universities that originally signed up to participate. Those universities were kind of whittled down through the competition. Many of them merged together and partnered together with one another. And we wound up with 9 teams representing 18 universities from 8 countries. And they ran an event on October 23rd at the Indianapolis Motor Speedway. It was a time trial event, so only one car at a time. It was very successful in terms of showcasing high-speed automation. We set all kinds of speed records for fastest speed, top speed, fastest lap, fastest 2-lap average. Our speeds were in the 150s, 157, I think was our top speed there. And when we completed that competition and gave out the $1 million prize to the winning team from Germany, Technical University of Munich, we realized that we still had more to show the world, and wanted to, take these cars and really demonstrate passing, which was always one of our core objectives. It wasn't just about going fast. We needed to show that autonomous vehicles could encounter one another and make decisions the way human drivers, make decisions about when to overtake or when to pass. And so we set out to run a second competition, passing competition, and thought, where better to do that than as part of CES, the biggest tech innovation show in the United States, again, arguably maybe in the world, held in Las Vegas every year in January. And so here we are during the week of CES, preparing for the Autonomous Challenge at CES, which will be held January 7th at the Las Vegas Motor Speedway. And it will include a passing competition where two cars will go on the track at the same time, and they will pass each other at increasingly higher speeds until one car is unable to overtake. And at that point, you'll declare a winner. They'll move on to the next round, and so on and so forth, until you've got a winner of that passing competition. Very excited about that format. It's never been done before. There's been no head-to-head racing of autonomous vehicles in the history of mankind. So it'll be another first for us.
Well, it's an absolutely fantastic idea and an event, and amazing sort of technology and everything. So I really appreciate your time and your insights. Thank you very much. I just have one last quick question. I know you're pushed for time, but I wanted to kind of ask you I know you said that the idea of this being spun out into an overall business, a bit like Formula One or IndyCar or NASCAR, they're big businesses in their own right. And I believe that this will become a big business. But on a slightly lower level, technical level, these teams that we're seeing on screen, do you hypothesize, or maybe even know, do you think any of them are going to become kind of car brands and launch cars based on the technology that they are developing and learning? Or do you think big automakers like in Formula One, Mercedes and all the other car makers are going to come in and sponsor individual teams, and then sort of do that kind of business model is going to happen? What kind of business model do you think is going to develop out of this?
So it's a lot to unpack there. I think that I think time will tell. Look, I'm confident that we have tremendous interest from our sponsors, which are really leading component manufacturers as opposed to whole vehicle manufacturers or OEMs. And I really do view that this competition is a way for component technology that's critical for autonomous vehicles to be proven out and advanced. And so I see that relationship continuing on into the future. These are university-based teams. And so, how they spin things out, how they create companies, what the objectives of those companies are, it's probably going to vary from university to university. Some of them are maybe more focused on applied research relationships with existing industry players, could be automakers. Others may be interested in licensing their technology, and others may look to create a brand new company. We'll be announcing later today that one of the companies or one of the teams, the team that won our event in October, Technical University of Munich, is spinning out a company called Drive Blocks that will be bringing autonomous algorithms and software into the marketplace. And so, I think time will tell what kind of ventures will emerge out of this. Just like with DARPA Grand Challenge, I don't think anyone could predict exactly how that was going to impact the industry. And looking back, I think everyone feels confident that we certainly would not be where we are today without the innovations that came out of the DARPA Grand Challenge. And hopefully 10 years or more from today, the people will say the same thing about the Indy Autonomous Challenge. So thank you very much. It's been great to chat with you, and look forward to reading your reports, and let's stay in close contact in the future. Thank you very much.
Thank you very much for your time and insight.
Take care.
Have a great day. Take care.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.